Okay, so today we're going to be talking about identifying linear functions. So we've already talked about recognizing what a function looks like. We know that the x's can't repeat. We know that it has to pass the vertical line test. And we know that for every x, there needs to be a unique y. Now we're going to talk about something specific, a certain type of function, and that's a linear function. Okay? We're going to be talking about linear functions. Now, what do you see in linear? What does a linear function look like? Well, if you look right here in the word, it says line. So we're going to be looking at functions that are straight lines. Okay? Now, when identifying a linear function, you need to check two things. You need to first, of course, see if it's a line. And what I mean by line, it needs to have a constant rate of change. We'll talk about what a constant rate of change means. We also need to make sure it is a function. For every x, there is a unique y. So now let's look at our graph. Now on a graph, it's easy to tell if it's a linear function. For instance, this right here, first, it's a function. It passes the vertical line test. There are no x's that are repeating, and it's linear. So this is a linear function. Now, if I were to draw this, this is a function. It passes the vertical line test. No x's are repeating, but it's in the shape of a parabola. So it's not linear. This is a function, but it's not a linear function. This is going to be a quadratic function, and you'll see when we get there. Now, let's look at equations. Now, equations are also easy to see if they're functions just by looking at them. Let's take a look at this one. Y equals 2x plus 4. If you were to graph this, you would get a straight line. This is linear. But just by looking at it, if you see that the x is of the first power and the y is of the first power, you know that it's linear. Now look at this one. I have x to the second power. When we graph this, this is going to create a parabola. Okay, this is not linear because x is to the second power, so this is not a linear function. Okay, now let's look at this one. 3 over x is equal to y. Anytime you have a variable in the denominator, this is not linear. When you graph this, you'll get something completely different. This is not linear when a variable is in the denominator. Now let's look at this one over here. The variable is not in the denominator, it's in the numerator. This is the same as writing 1/3 x is equal to y. This, if you look, the power of the x is 1 and the power of the y is 1. This is a function. This is a linear function. Just because x is in the numerator. Remember, it can't be in the denominator. Okay. Now let's look at this. This is the square root. Okay, is x to the first power? No, it's a square root. It's to the negative first power, and we'll talk about that later. So this is not a function. It's not a function. Okay, so this one is, I'm going to circle that, I'm going to circle that. Now what about our last example here? Is this a function? I want you to check your x, and I want you to check your y. If they're to the power 1, it's a function. Okay, so is this a function? It's a function. It's also a linear function. That's what I should have asked you. Is it a linear function? Yes, it is a linear function. Okay, it has x to the power of 1 and y to the power of 1. It is a linear function. Okay, so now we have some tables here. Now this is when we're going to talk about this constant rate of change. For what a constant rate of change means is the change in the x's and the change in the y's. So that's what this is down here. Your change in y over your change in x. Now let's look at the x's. From 1 to 2, we're going to positive 1. From 2 to 3, we're going to positive 1. From 3 to 4, we're going to positive 1. So all of these are a constant positive 1 rate of change. Now let's look at the y's. Okay, so from -5 to -3, we're decreasing by a -2. From a -3 to a -1, decreasing -2. -1 to 1, decreasing -2. So see, all of these are constant. So when you take the change in y, which is -2, over the change in x, it's all constant. So your rate of change here is -2. Okay? Now let's take a look at the second one. From 1 to 2, we're going to +1. From 2 to 4, we're going to +2. From 4 to 8, we're going to +4. Okay? These are not constant. These are not constant. Now let's look at our y's. From here, we're going to +5. We're going here, a +5. We're going here, a +5. So what's going on here? From here to here, we have 5 over 1, the change in y over the change of x. And then here we have 5 over 2, the change in y, the change of x. And then here we have 5 over 4. So this is not constant. This is not linear. So this is a big no, not linear. This one's a good check mark. Now let's take a look at the last one. Okay? So from 3 to 6, +3. From 6 to 9, +3. From 9 to 12, +3. Okay, so far so good. Now let's look at the y values. From 20 to 40, I'm going to +20. From 40 to 60, I'm going to +20. From 60 to 80, a +20. All right, so this looks good. My change in y is 20 over my change in x, which is 3. And that's constant. So this is my change in y over my change in x. This is my constant rate of change. It's constant throughout, so this is a linear function. Now, for the bottom one, what I want you to do. All right. For the bottom one, I froze. This is where I get technical difficulties. Now for the bottom one, you have a list of points. 3, 2, 4, 6, 5, 10, and 7, 18. I want you to set up your table just like this. I want you to write your x's. I want you to write your y's. I want you to do your change in your x, and I want you to do your change in your y. I want you to set it up just like this. Now be careful. Okay, just because there's a gap here doesn't mean it's not a function. It can still be a function if everything reduces. So this is what I want you to do and tell me if it's a function.